All right. In this question, we are told that the reading speed of second grade students in a large city is approximately normal, with a mean of 90 words per minute and a standard deviation of 10 words per minute, or WPM for short. And although you cannot see it right now, at the top of every question from this publisher and with the online homework system, there is a question ID that goes along with the related problem at the end of the section in the textbook, but some of them have a dash T, which means when you see a dash T, they're expecting you to use technology. We don't have an option to open up table 5 for the normal distributions. So we're asked, what is the probability of a randomly selected student in the city that student will read more than 96 words per minute? We can use the normal CDF command. So let's see here. If you were to draw a picture to go along with this, talking about reading more than 95 words per minute. Sorry, 96 words per minute. You would have it marked at 96 and then shaded to the right of that. Well, it continues infinitely. You can find someone reading faster and faster. The TI-84 does not have a way of typing in infinity, so we put in the largest number that it can handle. Most of them is going to be 10 to the 99th power. Some of the newer ones may be 10 to the 999th power. So I will go to second and vars, because above vars is DISTR, short for distribution. I picked the second one, not the first one. My lower bound is the 96. The upper bound is the 10 to the 99th power. Mu is 90 and sigma was 10. I was working on a similar question with a face-to-face class recently. And they want that rounded to 4 decimal places. So the 5 in the 5th place is going to round that to 0.2743, rounding to the nearest 10 thousandths. If 100 students were chosen, then by comparing this theoretical or classical approach to probability and think about comparing that to an empirical probability, a relative frequency, I would expect dividing the number of students by 100 would give me about 2743. So if I reverse that, multiply the 0.2743 by 100, I get 27.43, but it doesn't make sense to have 0.43 of a student. That would round down to 27 students. And notice that we've got a few different ways to talk about what those 27 students would be doing. But since we were asked back here in the probability of reading more than 96 words per minute, it's going to be choice A. And there we go. What is the probability that a random sample of 10 second grade students from the city results in a mean reading rate of more than 96 words per minute? We're talking about X bar now. In the first question, we were talking about the individual scores within the population. Now we are talking about the sampling distribution of X bar. So real quick, if I'd done the previous question, first calculating a z-score by hand, and then going to the table, in the case with this textbook, table 5, I would have been using z equals x minus mu over sigma. But now in this part of the question, since we're talking about the sampling distribution of X bar, I'm going to have X bar minus mu because mu of x bar is equal to the mu of the population, all over sigma divided by square root of n. You would want parentheses around the subtraction in the numerator and around the mini fraction in the denominator. That's going to change how we use the calculator. Oh. Okay. So you could go back to second and the vars to get into the distribution to call up normal CDF again. But this calculator lets me scroll back, copy and paste. So I'm about to do that and make a minor change because we're still talking about reading more than 96 words per minute. So it's changing here when we have this -t question where we're expected to use technology is that instead of sigma, we'll have sigma divided by square root of n. In this case, 10 is divided by square root of 10. Notice that how that got much lower. It's going to be more difficult to find a sample mean that is out in the extremes, out in the right-hand tail in this case, to get 10 of those children whose average has their reading speed being x bar being greater than 96. Harder to do that than it would be for an individual student. This is going to round again. We want to go to 4 places, and we have an 8 in the 10,000ths place, followed by another 8 in the 5th place. So that's going to round to 0.0289. And similar to the previous question, now if we had 100 independent samples, still with 10 students, multiply that by 100 and round. 2.89 would round up to 3, and we would expect that the X bar, on average, from those 100 independent samples of 10 students, that we would have X bar being greater than 96 in 3 of them. Greater than or more than 96 words per minute. All right, everything's working out okay so far. What is the probability that a random sample of 20 second grade students would have a mean reading rate of more than 96 words per minute? Instead of dividing the sigma, the standard deviation from the population that was 10, instead of dividing by square root of 10, now we're dividing by square root of 20. And now it's even less likely in a sample that's even larger. That's rounding to 0.0036. If I multiply that by 100, I'm only going to have 0.36, which would round to 0. We'd expect with 100 of independent samples of 20 students that it'd be almost impossible to find a sample where they were reading more than 96 words per minute on average. What's happening as n increases, we look back at this formula here. As n increases, square root of n is also going to increase. So sigma divided by square root of n is going to get smaller. The whole fraction, dividing what you have from the subtraction in the numerator, dividing by something that's getting smaller and smaller, you're going to get an overall fraction that's larger and larger. Now, it could be negative, so I really mean the absolute values are going to be larger, which means we're talking about something either in the extreme left or extreme right-hand tail. And that's going to be less and less likely to occur. So as n increases, sigma of X bar is going to decrease. And let's see here. The probability decreases because sigma of X bar decreases as n increases. That looks like that's the one. Okay, yes it is. And I think we have just this one last part, maybe two. The teacher has instituted a new reading program at school. After 10 weeks of the program, it was found that the mean reading speed of a random sample of 18 second grade students was 92.1. What might you conclude? Okay, well, let's treat it like the previous questions. 92.1 instead of 96, first of all. And second of all, sample size, n, is 18. I want to see if reading more than 92.1 would be something with a low probability, something where the score is extreme, so that we'd be talking about an unusual event. That is a relatively high probability. That would round to 0.1865. Which is not less than 0.05 or 15%. So it's not unusual. The probability was 0.1865, I think we had. Yes. Okay. 0.1865. That would mean that we could expect a reading rate, a mean reading rate, when we're talking about a simple random sample of 18 students. We should see that showing up. If we multiply this by 100 and then round, we would see that showing up in 19 out of every 100 random samples of size 18. And so this does not seem to be very unusual, and therefore not a program that is making a huge difference, apparently. Okay. I think this is the last part to this question. There's a 5% chance that the mean reading speed of a random sample of 22 second grade students will exceed what value? In this case, we are working backwards. If we had done those previous questions by hand, we would have calculated z-scores, then looked up in the table. So we would have gone from X bar to Z to a probability. Now they're giving us a probability or a proportion. Turn that 5% into 0.05. In the classical approach, you would have to find 0.05, i.e. 0.0500, or the closest thing to that within the table. Read backwards to find a z-score, and then do some algebra to find out the X bar. But since this is a -T, a technology question, then we need to use the opposite approach, the inverse norm, and we would use 0.05 for the area. The mean was it 90. Standard deviation was 10, and we are now dealing with a simple random sample of 22 students. So we would have 10 divided by square root of 22 for sigma. Now in this case, my calculator has some more options than some of you might have, so I'll tell you what you can do in a moment. But we're talking about shading to the right because we want their mean reading speed to exceed that value. So stick with that, shading to the right. And that's telling me that it would need to be 93.506 something, rounded two places. So 93.51 words per minute. Okay, now before I go on to another, what if you don't have those choices? By the way, if your calculator is old enough where you didn't even get a menu for the normal CDF command, if it puts you right back in the home screen, then you'll be putting lower bound, upper bound, mean, and standard deviation. In the case of the sampling distribution of X bar, that would be sigma over square root of n, in that order. Lower bound, upper bound, mean, and then the standard deviation, considering whether you're dealing with a population or the sampling distribution of X bar. That's the order that that goes in. Okay, so similarly, you may not get a menu to type these things in. It may put you in the home screen. You need commas in between. That's right above the 7. You can't see the 7 on my screen most likely, but commas right above that. So by default, the older TIs, the TI-83 or an older TI-84, is only going to the left. And I want you to see something here. Yeah. Let's do that again. Let's change that to going to the left. Because of the symmetry of normal distributions, if I find out how far that score on the left is from the mean, and then add that amount to the mean, then I should get the same answer of the 93.506 something. Let's see. Let me just do this. Not that one. We just found out how far the one on the left would be. That would cut off the bottom 5%. Now we want to go the other direction. If my thing will respond. There we go. Okay. 90 plus that amount. And you can see we're getting the same answer there. See what other questions we have.